Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the parent ring. The structure is a 5-membered carbocyclic ring, cyclopentane base, making it a cyclopentane derivative. Moving on to the next step. Identify the degree of unsaturation within the ring. There are 2 double bonds visible in the ring between C2, C3 and C4, C5, making the parent chain cyclopenta 2,4 diene. Moving on to the next step. Identify all substituents. There is a hydroxyl group, or a bromine atom, Br, and a chlorine atom, Cl, attached to the ring. And for the final step, assign numbering to give lowest locants to substituents. The carbon bearing the OH group is assigned C1 as ol suffix. The carbon bearing Br is adjacent to C1 and with the double bonds at C2, C3 and C4, C5, Br is at C2. The carbon bearing Cl is on the other side of C1, with the numbering going so that the double bonds get locants 2 and 4, Cl falls at C5. Verify the numbering. Going around the ring, C1 or C2 Br, part of C2 is equal to C3 double bond, C3 C4, part of C4 is equal to C5 double bond, C5 Cl. This gives double bonds at positions 2, 4 and substituents at 1 or 2 Br, 5 Cl, consistent with lowest locant set. Cyclopenta 2,4 diene 1 ol, cyclopentadienol with OH at C1. Add substituents alphabetically as prefixes, 2-bromo and 5-chloro. Full name, 2-bromo 5-chlorocyclopenta 2,4 diene 1 ol. No other options are present to eliminate, but alternative numbering, example, placing Cl at C2 and Br at C5, would give 5-bromo 2-chlorocyclopenta 2,4 diene 1 ol, which has a higher locant set, 2, 5, versus 2, 5, same set, so alphabetical order of substituents dictates bromo before chloro, confirming Br at C2. Therefore, the correct answer is 2-bromo 5-chlorocyclopenta 2,4 diene 1 ol. The correct answer is shown on screen.